Okay, part 4 in our single-ended tube amplifier build. Before we jump in though, I thought we'd light the fireworks here and celebrate a little bit. This is our 100th video on YouTube, and we're pretty excited about that. It's all happened here in about a year and a half that we've started making these things, so having a lot of fun, and maybe we'll get to 200 by this time next year. So hold tight, let's dive on into part 4 of the single-ended build. Before we jump into the bill of materials, I thought I'd answer a few questions out here because they're relative. These popped up as a result of part 3, and some of these are worthy of answering, and there's also a correction or two I need to do in here as a result. But the first one up here, this guy posed, he says, for a few reasons I'm wondering this. Can this power supply section of the amplifier be mounted separately from the main body to help avoid magnetic field interactions? And will there be any harm in using a separate heater supply transformer for reasons of lowering heat buildup and the problem that creates over time? Basically then saying enjoying this build. So a couple things here. Yes, you can separate all of this into multiple chassis. And I'll give you an example here. This is an amplifier I had built a while back. This is a radio frequency amplifier, about a 1,000-watt amplifier used for ham radio gear. But if you spun this amplifier around, what you'd see on the back side is down here in the bottom, you'd have the whole power supply section kind of on its own chassis. And then up here in the top, you'd have kind of the output tubes in a separate section. Now if you see here, and then you have this cable that comes from the bottom up and connects right here and then feeds across in here. This is actually the plate resistor. It goes up. Then it connects to this bar, copper bar that goes all the way across, which connects to the plate of the tube. There's about 6,000 volts sitting right there. If you'll notice, they have a separate transformer right here on this chassis just for the filament on this amplifier. So yeah, it's a great example of you can separate this stuff, but let me show you something. I just kind of drew this up of what it might look like, and we'll get into this more when we talk about layout, when we get into past the build of materials. But you might have one box here with the your choke and your power transformer and your 5U4 rectifier, and then you might have another chassis over here with your two output transformers, the two 807 tubes and your three 6S and 7 tubes. The problem is you've got to feed from here over to here with both high voltage, remember we're running about 450 volts, and you're going to have to feed your filament voltages across over here as well. And the problem is, yes, it can be done, and yes, you might get better separation here between the electromagnetic fields. But then you got to deal with this connectivity here, and these connections for 450 volts are not trivial. Besides that, if somebody came along and grabbed a hold of one of these wires, it's got 450 volts sitting on it. You're exposing high voltage outside the amplifier chassis. And two, this whole setup right here turns into a great big antenna. So when your cell phone syncs or various other things, the microwave in the house kicks off, if you don't shield this very, very well, you'll end up with this acting as an antenna. So there's kind of pros to it. There's also cons to doing it. And personally, I think the cons outweigh the pros. I know you see a lot of high-end amplifiers go this route. I think it's just as much about marketing and selling you two boxes and a higher end setup than it is one. I think you can build a really effective amplifier with all the transformers in one chassis if they're turned the right way. If you need to, you can put some shields over them, but I think you can do it in one chassis just as effectively as in two, and not incur the risk associated with this right here. Alright, up next somebody said a high efficiency speaker build for this would be cool. Probably won't see that. Sorry, I'm not much into building speakers. The next statement here is 3S, 6S, and 7s at 0.6 amps is 1.8 amps, not 1.2. So I'll take you to this slide, and they are correct. I had done some incorrect math. I had put 1.2 amps right here. The good news is 1.8, and thus I said 1.8 times 2 is 3.6. The good news is what I had recommended of either 4 or 5 amps stays the same. So either get a 4 amp or 5 amp transformer in this case. Let's see. Next, stupid question, but why maybe not R-core or triortal transformers not being used in vacuum tube gear? So you do see some. It's just pretty what I would call exotic. You don't see it done a lot. Toroidal transformers and as audio output transformers are very finicky, very subjective to, or very subjected to DC imbalance in the output tubes. And there's also an issue of air gap, which single-ended transformers need. Not that it can't be done, because there are some companies out there that actually make these things. It's just not a very common thing you see often. So I was sticking a little more traditional. Remember, I'm trying to build something everybody can afford here. The cheapest toroidal transformer I could find were about $500 or $600 per transformer. So somebody said they like the EdCore transformers. Yep, I've used them quite a bit and enjoy them myself. Then somebody said, I haven't said much about specific speakers I'll be using this with, because that's because I'm designing it to work with a lot of different speakers. I have no idea. I've got a dozen pair of high efficiency speakers sitting around here. I'm not sure what I'll be hooking it up to, but I will say get some high efficiency speakers. Then they started saying, I noticed you purchased some 8 ohm secondaries, likely yield high output impedance, da 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 da. Well, here's the reality. You can get 4 ohm speakers, you can get 8 ohm speakers, you can get 16 ohm speakers. EdCore sells the same with matching the 5K primaries that we were using in this. So you can go to EdCore's website and buy the matching output impedance however you would like. And I get what they're saying a little bit here about 8 ohms could have more variance than in 4 ohms, but I don't really think it's going to play out and make much of a difference at all here. I think 8 ohm speakers would be great with this setup. Same as if you went 16 or 4 ohms, you'd be fine either way. And then finally, somebody said, don't forget Lundahl. Yeah, when I was mentioning output transformers, you can get Lundahl transformers, really good made. I think they're made in the UK, if I'm not mistaken, but really good stuff. And same scenario, though, you end up with the high shipping costs. That's why I didn't go with the original ones that Dick recommended. But good stuff nonetheless. All right, one other statement I got from somebody, and they were absolutely correct, and I failed to mention this. I'm coming back around now to explain it a little better. But I mentioned that we were elevating the heater voltage in the power supply, if you'll remember, back up here. Let me see if I can find it real quick for you. Right here, if you remember this little setup right here where I talked about we had, at 450 volts, we're doing a voltage divider. This point right here was probably floating around 80 volts or so, and thus we were suspending the 6.3 volt AC heater voltage above ground by about 80 volts. So superimposing the 6.3 volts on top of an 80 volt DC offset. And I said that was done for noise rejection and to kind of quiet the heater noise. That is a true statement. It used to be done a lot in the 30s, 40s. A lot of the older Western Electric designs, etc., had that type of setup. But there's another reason that I failed to mention that's even more applicable to this scenario, and it's because of this SRPP circuit right here. If you'll notice the way this circuit works, you've got 350 volts sitting up here on the plate of this tube. And if you kind of walk down from the plate to ground here, if you'll notice, you've almost got two identical setups here. You've got a tube, a 1K, a 1K, you've got a tube, a 1K, a 1K, and then ground. And what you end up with is about halfway through here in the middle, you end up with about half of this 350 volts sitting right here on the cathode of this tube. So you've got some DC sitting right here. It gets decoupled right here and you just carry the AC through here because of this decoupling capacitor. However, you've got 175 volts sitting right here, and I need to take you over and show you something real quick. Okay, this is back to the 6S and 7 data sheet. And if you scroll down a little bit, you'll find something here called the heater to cathode voltage, which is an interesting specification we have yet to pay attention to in this video series, but we need to. And if you'll notice, it mentions two different kind of variations of this. One is the heater is positive with respect to the cathode. In other words, the heater voltage is sitting at a higher DC potential than the cathode of the tube, or the heater negative respect to the cathode. In other words, maybe the heater is grounded and the cathode is sitting at a higher voltage. And that's the scenario we've got going on right here. And if you'll notice, there's a maximum 200 volts of DC and peak. So let's come back over here to this picture. If you'll notice, most schematics omit the drawings of the heater, so I just drew them in here with some blue lines. Some schematics will actually show them, but a lot of them omit them just to keep the schematic from being cluttered, and they're kind of a given. You just feed them, they heat the tubes up. Not so much an actual part of the working circuit. But in this scenario, we've got to pay attention, because if we had not floated these heaters above ground to say 80 volts or so and left them grounded like you typically would see in a heater setup, then you would have a delta here between ground on this point and this area, this cathode, of 175 volts. Well, back over to that schematic that I had, it told us we had a 200 volt maximum, so I'm pushing it, and here's why. Because remember, it said DC plus peak. Well, you've already gone through 1 6s and 7 here, right? And then you're feeding over into this tube, and you're coming out of the plate of it with even a higher voltage swing, feeding into then this second half of the 6s and 7 right here. So you very well could be driving more than 20 or 25 volts peak to peak right in this area, which is going to be fed over and fed into the grid of this 807. So you're pushing the limit. So the way you get around that delta right here between these two is you float the heater voltage on this one. And remember, the original design, they were only floating the heater voltage on this. But what I mentioned was it wouldn't hurt to float the heater voltage on all of these tubes up to the 80 volt point. So even though we've got these cathodes here closer to ground, they're not outside of that specification that would be of the 200 volts here going the other way, the reverse polarity either. So we're in good shape. I just wanted you to understand the reason we're floating those heaters. It's because this cathode is sitting at 175 volts. If you put this at ground and then you got signal flowing here taking the 175 up or down more than 25 volts, you would have problems and could cause some issues here and burn this tube up basically. So that's the reason. Okay, the much anticipated and long overdue, we finally get to the bill of materials here. By the way, I said build of materials at one point in one of these videos, and somebody made a post and corrected me and said it's bill of materials. So, okay. Any rate, I last updated this one 4/23/2017. I keep all my schematics up in Google Docs. I mean, all my bill of materials here. Good thing about that is I can share it out and other people can get to it, and it's just a safe place for me to keep all my stuff. So let me walk you through this, just orient you a little bit to the schematic. I have my quantity here. I have the item that I kind of give it a name. It's basically what I call it. Then a specific part number, then the vendor I get it from, then a description, a little bit more detailed, the cost each, and the cost total, if that makes sense. I want to show you a couple things. In some cases, you'll see me say, hey, I got these parts off of eBay. That's very likely in some cases. And in other cases, I got them from very specific places like Parts Connection, the Tube Store. And then sometimes you'll see something here that says stock. Well, that means I'm pulling it out of my stock and I didn't have to actually order it. So before I share this out with the world, I'll go through and replace what says stock with some actual part numbers from one of these vendors, or maybe Mauser or somewhere, so you can obtain all this stuff. So let's kind of walk through this thing. First and foremost, you're going to need two 5-pin tube sockets, and that's the part number, and I got them from Parts Connection, and they are just a ceramic wafer tube socket. And let me show you that real quick. All right, and you can see here on Parts Connection website, this is just, and you can get these from a lot of places. It's just, sometimes I like to get stuff from a place where I can get more things from than less. So I'll start building an amplifier and laying out a parts list, and maybe I can get 20 things from this one vendor. So I'd rather get it there, even if maybe I pay a little bit more than having to go to 3 different places to get my parts, if that makes sense. And up next here we need, actually I can change that. We need 3 octal tube sockets. Hey, we just lowered the price of this amplifier. This Belton 75292, and if we jump over here, we can see there they have them. I really like these tube sockets a lot. I've used them many times. Really good quality tube sockets here for our octal tube sockets. And you can see $3.25 each. Okay, up next, I want to talk a little bit about this section I've got highlighted, the power supply filter capacitors. Remember before I said I had never built an amplifier and used MKP or probably polypropylene capacitors in the power supply. So I don't know how this is going to turn out. Dick did it, he liked it, so I thought, I'm going to give it a try myself, something new and exciting for me. But very likely I could get to the end of this and say, you know what? That's a lot of money. If you do the math on these capacitors right here, it's $103 worth of capacitors. And I may come back at the end and say, you know what? For $20 worth of electrolytics, I'd rather go that route. So that's kind of why I was saying heed my warning on don't go and buy a bunch of parts. I may tweak this thing along the way, and I'd hate for you to buy $100 worth of capacitors and then me come back and say, you know what, I think the electrolytics did a better job. So I don't know, we'll figure that out. We'll test that out on the bench as well. But you can get these things if you go to the Tube Store, which is it's another good website to get parts off of. It was about the only place I could find these things at, but you can see here they carry the Solene fast caps, 33 microfarad. They also carry, as you can see here, the 22 and the 10 microfarad. You can search for it on their website, but that should get you the filter capacitors. Okay, up next I've got this whole section here on resistors, and I'll probably pronounce this wrong, but Kwame resistors. I've had really good luck with these resistors in the past. A couple things to note: all these don't have to be 2 watt, but it's I went ahead and went with 2 watts because that's what they sell their resistors, kind of the minimum size. Some of these can be 1 watt, half watt, etc. But it doesn't hurt to go with a little bit higher wattage and get these resistors. One thing I like about them, they're 1% tolerance. 2, got really good sound to them. 3, they're flame proof. Let me show you here. Okay, here you go. Parts Connection sells these. I've used these before in building or repairing stuff, and I've been really impressed. Sometimes new modern resistors, metal film, etc., can have a little bit of a tinny sound to them as your signal, if your signal path flows through them. And carbon compound resistors, they can sound really warm. I think these right here are just a really good balance, really good, transparent resistor in an amplifier. And as you can see, they're not all that expensive. Most of these, they have all different sizes, but most of these run $1.10 a piece. Now, I will tell you that when I build this thing on the bench, which will be coming up in our next video or two, I'm not going to use those Kwames on my bench build. I'm going to just use some resistors I've got laying around in here. That way, if I tweak something along the way, maybe I want to change the bias a little bit. I haven't sunk a lot of money, as you can see here. It'd be $35 worth of resistors, but I'd hate to have the wrong thing and then have to place another order and pay for shipping again. So what I was going to do is wait on ordering all these resistors here until after we have actually, kind of tweaked this thing a little bit, and then in the final build I'll use these good resistors. Okay, up next you're going to need a 390 ohm 10 watt resistor, typically like in a little metal gold container, look like maybe a Dale But at any rate, I had picked some up off of eBay at a pretty good price. They looked like surplus, but they were really good resistors. Up next, oh, actually, I can kill this next line because we're not going to need that. Remember, I had removed the power supply, the high voltage switch, because I just don't believe in that. We can kill that. Up next, you're going to need some 100 microfarad, 160 volt, and 100 microfarad, 63 volt cathode bypass. This one here is kind of important. You want to get some audio grade capacitors, and I had picked some up off of eBay. Similarly, I'd gotten some good power supply capacitors here off of eBay. You got to be careful on eBay. Try to only buy from U.S. sellers. If you're here in the U.S., be careful. A lot of the stuff coming out of China and Hong Kong, Nikon-Cons, and other good capacitors, some of them are fake. So be careful. Up next, some coupling caps that just go between the in the various stages of the amplifier. You can go back to the tube store and pick those up. Just some Zener diodes. I had a bunch of them in stock, 100 volt and 75 volt. Let me go back to the schematic and show you how this is going to work right here. Okay, if you remember, what they're using the Zeners here for is a fixed voltage, basically on the screen right here of this 807, and they're trying to get 250 volts right here that is constant. And they're doing that by putting 3 Zeners in series with each other to get to a total of 250 volts. Well, they don't really care whether you use 3 Zeners, 4 Zeners, 1 Zener, 10 Zeners, whatever it takes to get you to this. So let's say you just had laying around 10 25 volt Zeners. You could put those in series. Now it's going to get a little clunky and inside your amplifier to string along 10 components in series, but it really doesn't matter. You want to get to a total of 250 volts here, and we're actually going to do that here by using, if you'll notice, I have some 75 volts and some 100 volts here at the house. What I was going to use is 2 75s, which will get you to 150 plus one 100 volt Zener. So it'll be 3 Zeners stacked in series with each other to bias the screen on the 807 tube. And if you'll remember, on the power transformer, the least expensive route you could have gone would have been this 6K 7VG from Allied, which is actually a Hammond transformer, at $52 each. And you could go with any of the others I recommended. You could also, the cheapest route was this, the EdCore 15 watt 5K single-ended output transformers at $41 a piece. Or you could go with some of the other options I gave you. You're also going to need 2 chokes in this thing, and let me show you that real quick here. If you'll remember, in the power supply right here, we actually have 2 chokes right here, because remember, we're doing what's called a split rail power supply. You got a 10 Henry here and a 10 Henry right here. If you'll remember the math we did earlier, we said we were going to use 100 milliamp. So Hammond makes a good one there. It's called the 158M, and I can show you that here on the bench in just a little bit. I had actually something I had picked up a while back. I had gotten a little LED bezel. I'm going to use that. These things were dirt cheap, 14 cents a piece. And I'm going to put a little blue LED on the front of this thing for the power. And those things were 8 cents a piece. And that's just to kind of go along with my blue glow little methodology there. Power supply switch. These are some little round rocker switches that I used. I got these off of eBay at 81 cents. You're going to need an IAC power connector. Mauser are the ones I use. Part numbers here. These are 84 cents. This is what your power cord will plug into in the back of your amplifier. I've got about a couple hundred fuse holders I picked up at surplus somewhere along the way, but I'll like I said, I'll fill these in with some part numbers you can use. And then you're going to want to put in probably a 2 amp slow blow in this thing. You're going to need some banana jacks, and I like these right here, which are the CMC 858S-AG. They're kind of expensive. They're $7.15 a piece. There's a lot of cheaper banana jacks you can use if you want to. The same as with the RCA jack. These are silver plated. CMCs. These are $4 and something a piece. So hey, I got $37 in connectivity on the back of the amp. But that's just stuff I like to use. You may use something. You can get something a whole lot less expensive if you wanted to. Some bottom plate screws I had picked up. You're going to need some terminal strips, just a little 5-lug strips inside of this thing to kind of use as termination points and tie off points. And I had picked up a couple, put in here a couple 3 lugs as well. And then you're going to probably want a solder lug, which will actually go down on the chassis that you can ground a wire to. It's basically a little tag that'll bolt to the chassis and ground to it. Here is this aluminum Hammond chassis I'd ordered 12 by 10 by 2. I have not built this yet, so I don't know if this amplifier fits well in this chassis. There again, a risk again if you're buying all this stuff now. So I may end up with a bigger chassis before I get done, but that's what I'm going to try to work this thing into. 2 output tubes. I've got a bunch of 807s, so I had kind of put that down here. But worst case, you can buy a matched pair on eBay for $10 a piece. Same with a good rectifier tube, 5U4. You can probably get that for like $2 or $3. Heck, I'll probably even change that to $5. I just happen to have a bunch of them in stock. Same with the 6S7s. You can probably get nice ones there for $5 a piece if you go used, or not used, but new old stock. If you bought new ones, you might be up in the $12 a piece range, etc. And then you're going to need these top caps, which let me show you those real quick. Okay, you're going to need these little things. Basically, you'll have a wire coming up from underneath the amplifier up into this thing, and this socket plugs into what's called the plate cap on top of the tube, and it will be carrying high voltage, so typically these things are kind of ceramic and really well shielded. And then you're going to need a 100K pot on the front end of this thing if you're going to put a volume. Typically, I use what's called a log taper, in other words, logarithmic taper. So as you turn the potentiometer, the swing from one side to the other, going from like 0 ohms to 10K, is logarithmic in nature, and that works well when you're dealing with volume, because volume is kind of a follow the way your ears hears the amount of power being put out as a logarithmic function as well. So sometimes you'll hear them called audio taper. Any rate, Parts Connection here has a pretty good one. This is actually a Audio Note brand, and they are kind of pricey, $32, but that's what it would look like, and you would use that for the potentiometer. I used to like the Alps Blue Velvet, and but they've kind of quit making them, or so I've been told, and everything that's out there at this point are kind of Chinese knockoffs at this point. So but I've used a couple of those and they've not been bad. They're usually about $20 a piece. So, and then you're going to have to pick out some 6mm knob. You could get you a chicken head knob or just whatever kind of knob that fits your needs cosmetically. I've probably got a bunch of knobs around here, so I'll steal something. And then I had kind of calculated in, hey, and on all this stuff, you're going to have about $50 worth of shipping. And let's just say you bought a knob at maybe $4. So parts on this thing, you're going to be sitting at about $600 worth of parts alone on building one of these amplifiers. So if you wonder why a good amplifier, and remember, I went with the cheapest transformer, output and power transformer in this thing at $600. If you bump that up a little bit, you could easily end up with anywhere between $700 to $1,000 worth of parts for this amplifier at the end of the day, and that's before you've built it at all. So when you see somebody that's got an amplifier for sale and they're wanting $1,000 for it, well, you might want to realize they may have $700-800, maybe more, worth of parts in that thing. Or sometimes if you see an amplifier and it's $3,000, but then you get to looking at it, maybe they use some really good output transformers and they've got $1,500 just in the output transformers. But that's kind of where I'm sitting at on this thing. Hopefully this bill of materials makes sense to you. I want to take you over to the bench and show you a couple pieces now that I've collected, and some of the considerations around that. And I just finished filming the bench part live, and it turns out to be about 30 minutes itself, so I'm already at 29 minutes on this video. I'm going to go ahead and break this up into 2 separate videos to keep this thing from being an hour long. So stay tuned. The other part will be up shortly. Having a lot of fun here. Hope you are too.